Hello and welcome. In this video, we're going to talk about higher order derivatives, meaning what happens if we take the derivative of a derivative or if we take the derivative of that derivative. But before we jump into that, let's go ahead and review some basic differentiation involving the different rules we have already learned. So go ahead and pause the video and work through 1, 2, and 3 on your own. And then unpause the video and see how you did. Okay, hopefully you've had time to work on your own. If we take the derivative of f in number 1, the 5 is going to drop down, so we get 5x to the 4th. The 2 is going to drop down, so we get minus 6x. Minus the derivative of tangent is secant squared x. For number 2, we're going to have to apply the product rule because we are multiplying cosecant by the quantity x squared minus 1. So let's pick cosecant to be our first function, x squared minus 1 to be our second function. The derivative of cosecant of x is negative cosecant x cotangent x. We're going to multiply that by x squared minus 1, and we're going to add that to regular cosecant x times the derivative of the green function, which is just 2x. And we're just going to leave it just like that. I'm going to bring number 3 down here. F of x is 3 sine of x over x squared. So we're going to use the quotient rule here. So here's my first function. Here's my second function. So f prime of x is going to equal the derivative of 3 sine of x is 3 cosine of x. I'm going to multiply that by x squared, and I'm going to stick it in front. Just looks a little easier to read that way. Minus 3 sine of x times the derivative of our bottom function, which is 2x. And that whole thing is going to be over the bottom function squared. So let me rewrite this so it's a little bit more readable. X squared cosine, actually 3x squared cosine x, minus 6x sine of x, and that is all over x to the 4th. X squared squared is x squared to the 4th. So now that we've spent some time reviewing the different rules that we have learned for finding derivatives, let's build on this. We can take the derivative of a derivative. That's called finding a higher order derivative, meaning more than just the first derivative. The best application of this is that we talked about how velocity is the rate of change of position, while acceleration is the rate of change of velocity, or it is the second derivative of position. So if I take the derivative of position once, I get velocity. If I take the second derivative of position, I get acceleration. We'll come back to that idea in a future video. So let's look at the notation here. We already know that this is the first derivative when I have f prime of x. If I have 2 little apostrophes, 2 prime symbols, that means that we have the second derivative. If we have 3, that means we have the third derivative. And sometimes when we get really high up, instead of having the little apostrophes, you'll actually just see a number. So f of 4 of x, meaning the 4th derivative of x. Or sometimes you'll even see that for the third or the second. But you should know that the number of little tick marks here, or the number, if there is a number written there, is telling you how many times you're taking the derivative, which derivative you are finding. So for this example in the box, we're finding the 4th derivative, which means we first need to find the first derivative. So the first derivative here, dropping my exponent down, would be 4x to the 3rd, dropping my exponent down, minus 6x plus 2. Now I'm just going to take the derivative of that derivative. So I'm going to drop this down to get 12x squared minus 6. The derivative of 2 is 0. And then I'm going to find the third derivative. That's going to give me 24x. And the derivative of negative 6 is 0. This was my third derivative. And then I'm going to find my 4th derivative, which is just going to be 24. And if I was asked to find the 5th derivative, I could do that. I would take the derivative of this, which would be 0. So you just go through the process that we've been learning as many times as you are required to find the derivative that is being asked. Let's look at some more examples. Okay, so we're going to find the indicated derivatives. The first thing we're going to do is find the first derivative, which here is just 4x. And then we're going to find the second derivative, the derivative of the derivative, which is going to be 4. Number 5 is asking us to find the third derivative, and they actually gave us the first derivative. So when we find the derivative now, we're starting at the second. The derivative of cosine is negative sine. And then to find the third, the derivative of negative sine is negative cosine. For number 6, we're finding the second derivative given this original function, and we're going to have to work with the quotient rule here a bit. So let's go ahead and find the first derivative. That's going to be 1 times x minus 2, the derivative of the numerator times the denominator, minus x times the derivative of the denominator, which is just 1, all over x minus 2 quantity squared. And since we're going to be using this to find another derivative, let's simplify a little bit here. The numerator is going to become x minus 2 minus x, which is just going to be minus 2 over x minus 2 quantity squared. Now we're going to find the derivative of that. Well, the derivative of the numerator, and actually we could rewrite this as negative 2 times x to the negative x minus 2 to the negative second power. We actually haven't talked about how to find the derivative of something like this. That'll come in a future video, but this is going to involve using the chain rule. Anyways, looking back at where we actually are, the derivative of the numerator is 0, and I'm going to write out all of these steps anyways, but this whole term is just going to become 0 minus negative 2 times the derivative of the denominator, which is going to be 2 times x minus 2. If I drop that exponent down, and then we're going to divide the whole thing by x minus 2 quantity squared. And let's go ahead and clean this up. That's going to be negative 4 times x minus 2 over x minus 2 quantity squared, so x minus 2 to the 4th. We're going to leave it just like that. Why don't you go ahead and pause the video and work through number 7 on your own. Hopefully you had time to do that. The first derivative for number 7 is going to be 2 times negative 4.9, which is going to be negative 9.8x plus 7. And then the second derivative is going to be just negative 9.8. So as we started to see in number 6, sometimes we sort of have a function inside of another function. I had something to the second power, and then I had something inside that function. That's going to lead us into the next section, which is about how do I find the derivative when I have a composition of functions, or how do I find the derivative using the chain rule. So let's recap what we learned in this video, and go ahead and check out that video if you're interested in seeing more about that. So in this video, we reviewed the product rule, the quotient rule, and finding derivatives involving the power rule and trig. Then we talked about what it means for something to be a higher order derivative, to find the derivative of a derivative, the first or second or third or fourth derivative, and we reviewed that notation. And then we wrapped up by completing some examples involving finding higher order derivatives. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.